Efficiency.
Well, through efficiency.
Lucid CEO Rawlinson keeps talking about Lucid's efficiency in almost every interview he's on. But what exactly does that mean? And how does Lucid's efficiency compare to Tesla's efficiency? Just looking at the plate numbers from the newest Model S and comparing it with Lucid's upcoming Air models, it means that the Lucid Air can drive around 0.6 miles more per kilowatt hour than the Tesla Model S with the same battery capacity. Or in other words, Lucid is around 15 to 17% more efficient than Tesla. We know that the batteries are the largest cost driver for EVs now and will be the biggest bottleneck in the coming decades. So, getting more out of the battery technology is Number 1, reacting to Stephen Mark Ryan. Number 2, deep dive. What's efficiency exactly? And number 3, bonus fact. We're going to reveal a bonus point last, so make sure to watch until the end.
But as I said, this graphic doesn't actually factor into the equation the mass of the vehicle, which is what we're going to do now to get a true picture of the engineering prowess of Tesla and how far ahead of the so-called competition they really are. The absolute best way to visualize this data is in table form, which is exactly what we're looking at now. Again, shout out to Matty Mogul for putting this together. It's a few months old, but the numbers speak for themselves. Core efficiency here is being calculated by factoring in the battery capacity in kilowatt hours, the miles of range achieved, and the mass of the vehicle. This is the most useful metric in terms of understanding the quality of the engineering in an electric vehicle. And we can see Tesla sitting on top of the table.
We are big fans of Stephen Mark Ryan's YouTube channel Solving the Money Problem, and he was one of the reasons we created our channel, along with Rob Maura from Tesla Daily. We've been Tesla investors since 2017, and to be clear, we don't think Lucid is the next Tesla. We even made a video about this. So overall, we totally agree with Stephen's main arguments, including his point that weight is a key factor in determining efficiency in this particular clip. But being a channel with a focus on Lucid, we had to add Lucid's numbers and also update it for Tesla's two newest Model S versions, the 2021 Plaid and the long-range version, since the presented table was posted in March this year and has outdated numbers. To be fair, we need to point out that Lucid Air is not out yet, and we trust the non-verified EPA numbers that Lucid made public. However, we expect to get the official EPA numbers very soon, since they are currently verifying it. The same can be said about Rivian and its numbers, which haven't been verified yet, but Rivian was still included in the table, so we think it's only reasonable to include Lucid as well. From our perspective, it's not a surprise that Lucid is leading efficiency with all the 4 models to be released. People often forget that Lucid has been a company since 2007. For the first 9 years, it was solely focused on assembling electric vehicle batteries and building powertrains for other vehicle manufacturers. The most noteworthy example is that Lucid supplies 100% of the Formula E teams with their battery technology. Before Lucid became the battery tech supplier, the racing cars had to stop during the race and swap cars in a time-pressured environment. So it's fair to assume that in the last 15 years, Lucid actually achieved some impressive engineering milestones. On top of this, remember that 40% of Lucid's leadership is from Tesla, and they have the second mover advantage, having learned from Tesla's challenges. But what exactly is Lucid doing differently than Tesla? Deep dive tech analysis. This video by Donut Media makes an excellent introduction to understand why Lucid has better efficiency than Tesla.
Now, Peter told me that the battery pack on the Lucid is 85% mechanical engineering problem and a 15% electrical engineering problem. So instead of focusing on developing a new lithium-ion chemistry to improve efficiency, they focused on designing the pack in a mechanical sense that allows for it to be smaller and therefore lighter.
One of the key differences is that Lucid is focused on mechanical engineering, whereas Tesla is seemingly focused on electrical engineering, where the idea is to improve the lithium-ion chemistry, in other words, the battery cells themselves. Now, if the difference is 85% to 15%, it makes sense to double down on the mechanics rather than the electronics. And as Tesla will need to use its 4680 battery cells themselves in the coming years, due to so many vehicles planned in the pipeline, it's easier for Lucid to supply its technology to other car manufacturers. Tesla is definitely by far the leader in terms of AI and autonomous driving. They are likely to eventually license this to other car manufacturers, but this has little to do with how efficient your car is. And when talking about the EV revolution, efficiency and having the best EV technology is what matters the most for car manufacturers currently. Our channel is for long-term investors, and we only make videos about topics that the media is not addressing because we value your time. In this video, our main message is that Lucid has the most efficient EV technology, even better than Tesla's, and we explain why exactly this is the case. If you see value in this video and would like us to reach more viewers, please consider liking this video so that the YouTube algorithm does its work. Thank you. The second point in our deep dive tech analysis takes a look at the drive unit, which is what Lucid is most proud about. In comparison to Tesla, Lucid's motors are lighter and have more power. This comparison is based on Lucid having drive units which weigh 74 kilograms or 163 pounds and 650 horsepower as the power output, which according to Lucid creates by far the greatest power to weight ratio. Before the new Tesla Model S came out in June, this also seemed to make sense, and as from what we found on the internet, we can assume that the Model S drive unit weighed 90 kilograms or 198 pounds and had 300 horsepower, which gave the Model S an output of around 3.3. In Lucid's presentation, it is shown as 3.2. This is clearly inferior to Lucid's score of 9, almost 3 times as good as Tesla. So the real question is to compare Lucid's drive unit with the newest Tesla Model S drive unit. There are no official numbers out in terms of weight and horsepower, but we found this clip by drag time.
Actually the same thing as those two over there, but that has 2 sandwiches on each side and goes to each drive shaft right there. Each one, he says, is making about 400 horsepower.
Who asked a Tesla engineer and found out that the newest drive unit has 400 horsepower, 100 more than the previous Model S, but still 250 horsepower less than Lucid Air's drive unit. As for the weight, Elon Musk stated in the Model S delivery event that you can hold the newest Tesla drive unit with your hands. Elon Musk is a tall and a strong person. Sometimes he's exaggerating, so we think that it's likely he's talking of at most 160 pounds, which would be a significant improvement from the previous Model S drive unit, which weighs 198 pounds. Also, we took a look at Lucid's drive unit, which weighs 163 pounds and still looks smaller than Tesla's drive unit, which likely cannot be put into a carry-on bag.
It's hard to see how tiny this motor is without something to scale, and I wish I put my phone next to it for you to see, but I would say it definitely fits in a carry-on bag.
So realistically, Tesla's newest drive unit would have a power to weight ratio of 5.5. This is still significantly lower than Lucid's score of 9. So even the newest Model S drive unit is not as efficient as Lucid's drive unit. Let's move on to point number 3.
So Lucid, they did something cool. They developed a special way to cool the part that gets the hottest, and that's the coils. And there are a few ways you can cool electric motors. You can just wrap the motor in some sort of cooling jacket. You can put passages inside the metal housing and pump cooling through that, but no one has been able to do what Lucid does. They developed an axial jet cooling manifold that butts up to the copper wire windings and allows for an almost direct contact to the wire. And by cooling the wires as directly as possible, they're able to reduce the amount of heat, thereby decreasing the resistance in the wire, increasing their efficiency.
It's not just the battery that needs to be constantly cooled, but also the drive unit itself, unless you want to lose efficiency. So what Lucid did was to identify several dead zones in the stationary part of the electric motor that could be used to bring the coolant closer to the wires. Rawlinson said that no one really had identified these areas before, these places where you can't get any flux. We first thought just to remove the material and put some holes in to save weight, but then we realized that we can bring the cooling systems through those areas right to the core of our motor. Moving on to the bonus fact.
When you use larger voltages to deliver the same amount of power, you need less current. You use more pressure in a smaller pipe. Now Tesla in their long-range Model S uses a battery that's 350 volts. So if they were to try and deliver the same amount of power as Lucid, they would have to have almost 3 times as much current. And like when we talked about the motors, the more current you have, the more losses you incur. Double the current, you multiply your losses by 4. It's called I²R losses. And with this high voltage design architecture, it means they can use lower currents, which means smaller cables and wires, which means less resistance, less mass of material, which in the end of the day equals a more efficient vehicle. Now, Lucid uses 22 battery modules to make a complete pack for the Air. Each module produces 42 volts for a sum total of 924 volts and a package that weighs just about 1,100 pounds. Each module makes a smudge over 5 kilowatt hours, and when you get 22 of them, you get your 113 kilowatt hour battery. And this is the battery configuration that gets you 517 miles on a full charge, which comes out to around 4.6 miles per kilowatt hour.
Voltage is like the pressure in a pipe, while current is the diameter of the pipe. So Lucid took advantage by opting for second generation ultra high voltage architecture of 900 volt, while Tesla systems and vehicles adopted around 400 volt, largely as a consequence of earlier technology. Even as the battery pack of the new Model S received a voltage bump to 450 volt, Lucid charges roughly 20% faster than a Tesla based on our estimates. So again, we overall agree with Steven from Solving the Money Problem, but we think Lucid should also be included when comparing efficiency in EVs. We hope he and other Tesla YouTubers see this video as well. If you saw value in this video and would like to help us reach more people, please hit the like button. After all, we all want to learn all about EVs and how they will transform the world. Vielen Dank.